The idea of an inverse function, f inverse of x, written like this, is that it undoes what a function f does. I'm not entirely happy about this notation f to the minus 1. It makes it sound like it's reciprocal of f. Not really. Very different critter. But at any rate, okay, f inverse of f of x equals x. F of n inverse of x equals x. So whatever x does, whatever f does to x, f inverse undoes it, and vice versa. So in other words, y equals f inverse of x, if and only if f of y equals x. So if f inverse, you can think of it as what happens when you transpose f. So it's an opposite operation. For example, a function x plus 7, its inverse is x minus 7. You subtract 7, opposite of adding 7. The inverse of the function 2x is the function x over 2. The inverse of the function x cubed is a function cube root of x. Now, when we graph them, we'll see an interesting thing here. Here's a graph of y equals x plus 7. Here's a graph of y equals x minus 7. You can see they're symmetric around this diagonal line, y equals x. Here's a graph of y equals 2x. Here's a graph of y equals a half x. And if you flip through the diagonal line, they get each other. Here, this is a graph of y equals x cubed. This is a graph of y equals cube root of x. And again, they're symmetrical to each other when you flip through the diagonal line. In general, if you have a function y equals f of x, its inverse can be found by flipping through the diagonal line like this. Because when you flip through the diagonal line, you turn y equals f of x into x equals f of y, and by definition of f inverse, it's the same as y equals f inverse. So you graph f inverse by graphing f and flip through the diagonal. To find a formula for an inverse function, you start with this, x equals f of y, and then you solve for y. So for example, let's find the inverse of this function, 1 plus the cube root of 2x. So y equals f inverse means f of y equals x, and then here we put y into this formula. So you get 1 plus cube root of 2y here. 1 plus cube root of 2y equals x. This is f of y equals x. Now we solve for y. We first subtract the 1, cube root of 2y equals x minus 1, then cube both sides, 2y equals x minus 1 all cubed, then divide by 2, x minus 1 all cubed divided by 2, and that's the inverse function. This is f, the inverse function is this. X minus 1, that cubed, that over 2. Now if you look at these things, here's what happens. If you look at f of x, you start with x, then you double it, and you take a cube root, and you add 1, and that's f of x. F inverse, you start with x, you subtract 1, then you cube it, and you take half. Now, times 2 divided by 2, cube root, cube, 1 plus, minus 1. These are opposite, these inverse functions are opposite operations in opposite order. So they undo each other. Now here we have a function y equals x cubed. And if I flip that through the diagonal, you get this graph. But that's not a graph of a function because a vertical line will meet it generally 2 places, here and here. Now this upper half of the sideways parabola, that's the graph is of y equals plus the cube root of x, square root of x. This lower half is the graph of y equals minus the square root of x. So really this is a graph of 2 functions. Now that's going to be inconvenient, which inverse function to use at which time and so on. So the book makes a point that you have to distinguish. When you have something like this where you don't have a single inverse, that's because, let's say, this function sends 2 values to the same value. It sends 2 to 4 and negative 2 to 4. So inverting, it doesn't know which to send 4 to 2 or minus 2. Now, we call a function 1 to 1 if it sends different inputs to different outputs. A not equal to B means f of A not equal to f of B. That corresponds to f having a single inverse. F has a single inverse if and only if it's defined this way, 1 to 1. If only if it graphs, it passes the horizontal line path test. Here's a graph Horizontal line. Any horizontal line passes through this graph once. So it passes that test. So it's a one-to-one function that sends, it sends different values to different values. And therefore it has a single inverse. If you flip this graph on its side, you won't get any doubling up like this does. This, however, does not pass the horizontal line test. It means a horizontal line twice, and so it doesn't have a single inverse. It has a pair of inverses. That's for example. Here we have a function, y equals 2.7 to the x. Is this function one-to-one? Yeah, and the horizontal line meets it once. So yes, it is, and so therefore it has a single inverse. Is this function one-to-one? No, it's not. This horizontal line meets it twice, so does this, and so on. So no, it's not one-to-one. Okay, let's invert the function 2x minus 1. So y equals f inverse of x means f of y equals x. That's the definition. So plugging in a y in here, you get 2y minus 1 equals x. 2 minus y minus 1 equals x. We solve for y. All right, first add 1 to both sides. 2y equals x plus 1. Divide both sides by 2. Y equals x plus 1 over 2. And that's the inverse function. Inverse function of x is x plus 1 over 2. These are inverses. And you can see why. This takes x, doubles, and subtracts 1. This takes x, adds 1, and halves. Opposite operations in opposite order. Now, it's not immediately obvious in this case how to do an inverse. Invert f of x equals x plus 4 over x minus 3. So we go through the same thing before. Y equals f inverse of x, so f of y equals x. So plugging in a y here, y plus 4 over y minus 3 equals x. And here we want to solve for y. All right, first thing is this annoying denominator, so we transpose it. Y plus 4 equals x times y minus 3. Then we'll distribute the x. So y plus 4 equals, distributing here, we get xy minus 3x. Y plus 4 equals xy minus 3x. Now I want to solve for y, so let's move this to the left and this 4 to the right. Subtract the 4 to transpose right, subtract the xy to transpose it left. When you do that, you get y minus xy equals minus 3x plus 4. Minus 4, minus 3x minus 4. Now on this side, we have all the y's on this side, but not in one place. We can get in one place by distributing. Get y times 1 minus x on the left. On the right, minus 3x minus 4. Next step, we divide by 1 minus x so as to isolate y. So you get y equals minus 3x minus 4 over 1 minus x. And there's your inverse function. Minus 3x minus 4 over 1 minus x is the inverse of this function. Okay, let's inverse cube root of x minus 7. All right, same deal. Y equals f inverse of x, f of y equals x. Plugging in here, fifth root of y minus 7 equals x. And solve for y. Okay, I always undo the last thing done. So the last thing done here, you take y, subtract 7, take fifth root, undo the fifth root by taking fifth power of both sides. On the left, you get y minus 7, and on the right, you get x to the fifth. Okay, here to isolate y, we just add 7 to both sides. Get y equals x to the fifth plus 7. And that's the inverse function to this. And again, inverse operations in inverse order. This takes x, subtracts 7, takes fifth root. This takes x, takes fifth power, adds 7. All right, here we have this function here, like this function here. They're called linear fractional equation functions because of the fraction with two linear functions. So I'm going to invert that. Y equals f inverse of x. So f of y equals x. So plug in y here and here. Y plus 1 over y minus 3 is equal to x. Now, okay, we do as they did the previous linear fractional function. We multiply both sides by y minus 3 to get this. We distribute the x, so y plus 1 equals xy minus 3x. Now, we want to move this term with a y to the left. We want to move this term with a 1 to the right. So you subtract 1 from both sides, subtract xy from both sides. And you get y minus xy on the left equals minus 3x minus 1 on the right. Okay, here we have y in both these terms, so we distribute it out. Y times 1 minus x is equal to minus 3x minus 1. Divide by 1 minus x, I get y equals minus 3x minus 1 over 1 minus x. And that is the inverse function to this. Here we have C is 5/9 of f minus 32. This converts from Fahrenheit degrees to Celsius degrees. And they ask, okay, first we'll just do some substitution. When f is 59, what's C? When f is -4, what's C? So 59 Fahrenheit is what Celsius? -4 Fahrenheit is what Celsius? And then let's invert, find f in terms of C. Okay. For the first two, it's pretty simple. Just plug in 59 in for f here. 5/9 of 59 minus 32, which is 5/9 of 27. And after some canceling, you get 15. So 59 Fahrenheit is 15 degrees Celsius. F equals -4, plug it in. C of -4 is 5/9 of -4 minus 32, which is 5/9 times -36. And after multiplying, that's -20. So 4 below 0 in Fahrenheit is 20 below in Celsius. Now, here to find f in terms of C. All right, let's first undo the 5/9 by multiplying both sides by 9/5. Cancels on the right, and on the left you get 9/5 C. That equals f minus 32. Then to isolate f, we add 32 to both sides, and here's the formula. 9/5 C plus 32 equals f. This is Celsius to Fahrenheit. You have a function of this. Here's a function. It's inverse. How does it graph that? You just flip through the diagonal, and you get a graph like this. All right. Stop.